Okay, this is the introduction for lesson 96 in math for Wednesday. And we're going to be talking about functions and graphing those functions. And functions are interesting. It's almost like you're being a human computer. You got an input and an output. Let me pull the book over here a minute and focus in on that. They make a nice table for you. And what they're talking about here is something, well, here, let me do this a minute. If I have a rectangular prism, let's say, and it's a cube, I better back this up a little bit. And so all sides are equal, okay? And each side is, let's say, we'll go 2 by 2. And that's the part you can't see, okay? And then the height is 2. Now, each face would be 2 by 2. So each face would have 4 square, whatever they are, let's say centimeters. And that means this front face would be 4. This face would be 4. This face would be 4. This backside face would be 4. The backside over there would be 4. Okay? 4, 4, 4, 4, 4. And there are 6 faces, a front and a back, a top and a bottom, and a side, right? So if I said to you, if the face was 4 centimeters squared, that means the entire cube would be, because it's times 6, 24 centimeters squared. That means the entire, what we call surface area. All right, now if we follow that, kind of make a table, because I love tables, and you say, well, what if each side was 3 by 3 by 3? Well, then each face would be 9 centimeters squared. Well, if that's the case, then what would be the total surface area of all 6 sides? Well, it's just times 6, so 54 centimeters squared. If it was 4 by 4, then each face would be 16 centimeters squared times 6. Just trust me, it's 96 centimeters squared, total surface area. If each side was 5 by 5, well, then each face would be 25 centimeters squared. If I multiply that by 6, I get 150 centimeters squared. Now let's say you walked up to this table and you didn't know this one. And you say, hey, here's a function table. What do you think's going on here? What do you think the rule is of the function? If I said, hey, this represents S, and this represents, and that would mean side, and that would be surface area, or total surface area. You look at this, I say, 4 to 24, that looks like it's times 6, or plus 20. It's either times 6 or plus 20. I wonder which one. Then you come over here and you say, if I plus 20 here, I only get to 36. But if I times 6, that works out. And the same thing here. So the rule of this function is times 6. So whatever this is equals this, S, times 6. Okay. You know, the other cool thing is if we were to graph this, now I don't have enough boxes on this, but if it was 4 this way and 24 up there, then 9 this way, and what was that, 54? 54 up there. This would go off my graph, but it would form a straight line. It's the craziest cool thing. I'll show you here in a minute. All right, so if I use the next example out of the book, it says, find the rule for this function. So how about you don't look at your book, but just look at this table, because I'm going to leave one out. And we're going to call this side L, side M. And you get 4 boxes worth right there. It's a 5, a 7, a 10, a 15, a 20. I'm going to skip one, 25, 30. I want you to pause a minute, look at that. Pause the video if you need to, and figure out, okay, what's happening? Are we adding something? Are we multiplying? What's the deal? So here we could say that we're adding 15 or we're multiplying by 4, right? This one we don't know. Are we adding 15 or multiplying by 4? Or sorry, yeah. Multiplying by 4 would get us to 40. We're adding 15 just like this one. To confirm our suspicion here, yeah, we add 15, we get that. So it must be adding 15 must be our rule. So 7 plus 15 is got to be what? Well, 22. There's our missing number. Okay. Sometimes they give you the rule in the table. See a sideways one here as an example. And it doesn't matter if it's sideways. Same deal. They give an x here and then a 3x minus 2. Okay. If I give you all these, 2, 3, 4, and I plug the 2 in, like I plug it right into there, that would be multiplication because it's just next to each other. So it'd be 6 minus 2, 4. 3, I plug that one in. That'd be 3 times 3, which is 9, minus 2. The answer would be 7. Take a minute, or pause the video. What do you think that one's going to be? Plug it into the x. Okay, if you had 4 in here, it'd be 3 times 4 is 12, minus 2. Missing number's 10. Now, let's take those a minute and see if we can put them on our graph. Now, it might go off this graph, so I'm actually going to change this graph. I'm going to put it sideways for 1, and I'm going to take my origin, that's where the 0, 0 is, and I'm going to move it down here. Because I know all these are positives, I know that they're all going to be in this quadrant, so it's okay if I make my x-axis down here like this, to give myself room, my y like that, because I know I'm going to be playing with this quadrant. Now let's look at it here. 2, 4. It would be like, it'd be written like that, 2, 4, right? So that's positive 2, positive 4. 1, 2, 3, 4. The next one is 3, 7. 1, 2, 3. 4, 5, 6, 7. And then my next one is 4, 10. Here's 4. I know this is 7. 8, 9, 10. Okay, and what I got is a straight line that goes straight through. And you know what you could do? You could take out a ruler and create a line that goes up, and you'd know what all the next boxes were beyond here just by using that coordinate plane. You'll have fun with that in junior high. We just kind of scratched the surface of it here. The next graphing function out of the book gives us, it says 1, 4. It's in a graph like that, but 2, 8, 3, 12, and 4, 16. Okay, so if I graph those will go in a straight line. But what I'm going to do is I'm going to do the top one and the bottom one, and then draw a line and see if we hit 2, 8, and 3, 12. So 1, 4 will be over 1, up 4. 1, 2, 3, 4. That's my 1, 4. And 4, 16, 1, 2, 3, 4. And then 16 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to put a 10 here just in case I lose my spot. 11, 12, 13, 14, 15, 16. Oh boy, I'm going to need a straight edge here. And I know I'm off the video here, but trust me, I'm doing it. Okay, so this spot right there was where it crossed, right there. And maybe not so perfect, but 2, 8, 1, 2, 3, 4, 5, 6, 7, 8. You're close, Terpstra. And then 3, 12. 3 and then 8, 9, 10, 11, 12. Okay? I probably could have done a better job of that, but you see where those end up perfectly. Okay, for today's assignment, I need you to do the practice set. And then it's A, B, C, D, E. So that's 5 of them. And then the assignment is 15 odds. Okay?